today. Before we get started, I just wanted to give a few words to our sponsor, which is Microsoft Norway. So they have this cloud challenge that you can learn more about Bicep on Microsoft Learn. They have about 1.5 hours of content with which is module based, where you can go through and get some hands-on, for example, after this session or during lunch in the coming days, to get some hands-on on what you will get to see today. And then you can also participate and win a cool backpack from Microsoft. If you also haven't seen it before, Microsoft also has this Azure Heroes program, so you can earn a digital badge by participating. So I will paste the links in the chat after we start, so we can get started with it. So let's introduce our presenters for the day. Esther, she works as a solution architect at Cognition IT, where she combines her passion for designing and implementing Citrix solution with her newfound love for DevOps automation using PowerShell, REST APIs, and JSON payloads to automate both on-premises and cloud infrastructure as code solutions. While Frank works as an infrastructure specialist at Barthel, a system integrator company based in the Netherlands, where he focuses on end-user computing and all related technologies, mostly on the Microsoft platform. Both of them have been awarded the Microsoft MVP Award. And I also wanted to start by thanking you for joining us today. The virtual stage is yours.
Thank you very much, and we're honored to be here today and to share some of the fun that we've been having with Bicep so far. So I'm just quickly going to share my screen with you all, and then we're just going to dive right into it. So for those of you who do not know me already, first of all, Jan, thank you very much for that wonderful introduction. I think you even did a better job describing Freek or introducing Freek than I'll probably do. But for those of you who do not know us already, so my name is Esther Barthel. I've been working with end user computing for over 20 years now. And the last couple of years, having a lot of fun with automating deployments, configurations of Windows infrastructure environments. And I think this last year I've been teaming up with Freek to make sure that we share the fun that we are having with infrastructure as code, especially now using Bicep with you all. So Freek, I'll let you introduce yourself first, and then we'll just get started.
Yeah, sure. So my name is Freek Bresson, like Esther from the Netherlands. Like introduction said, primarily focus on application and desktop deliveries. So technologies like Azure Virtual Desktop, WVD, a lot of RDS deployments in the past, but also enjoy working with automation and in particular infrastructure as code. Took the deep dive into Bicep about a year ago, and well, like Esther said, we enjoy sharing that knowledge. I think this is our 10th or 11th session already, so I've been doing a lot of those, and happy to be here to share this topic with you today. So this, like I said, not the first time we are presenting together, and I sort of created this van a couple of editions ago. It started out as a joke, because it's almost started to feel like doing a roadshow together. And so Esther, I think it was you who said, well, I enjoy doing that roadshow together with you, but this is not really what I had in mind in terms of the van. So Esther, actually,
I have to be honest. I like to travel a bit more in style, and I'm not totally a glamour girl, but I do love to have a bit more fun while we're on the road. So this is basically the suggested interior that I said. I fully understand that we want to be a bit incognito with the van that Freek picked, but I definitely want to make sure that we could invite all our friends with a nice, cool, fun interior. So just a little joke to take the edge of any nervousness that we might have in this presentation. And I think this is also a great introduction to make sure that we invite you to make it as interactive as we can. So if you have any questions during the demos that we're showing, feel free to reach out, ask them right away, either in the chat or speak up, unmute yourself. because we love to have a discussion on it. And to make sure that we challenge you as well as we are challenged with Bicep, we wanted to ask you to tweet or post on LinkedIn to make some noise for our session, but to also get a chance to win this awesome Getting Started with Bicep book that Freek wrote. And yes, I have a copy of my own because I really needed it to prepare the demos. So diving right into the agenda. So I'll let you start up all the socials and make some noise. Today, we want to focus on the Bicep architecture and just quickly go over it, because the main focus of this presentation is all the cool demos that we prepared. And of course, in the end, we will show you some of the roadmap and have our own call to actions to make sure that this is a very active community project that we can all benefit from. So diving into Bicep, if we want to dive into Bicep, you also need to understand that the base of Bicep and where it all got started is the Azure Resource Manager. This is the heart of infrastructure as code, or automating any deployments or configurations within Azure. And for those of you who are already familiar with the Azure Resource Manager, there are already different ways to communicate with the Azure Resource Manager by using ARM templates, either through a CLI or PowerShell or the REST API. And one of the things that I experience with creating ARM templates is that it's not always as easy or intuitive to get started with it. And Microsoft does acknowledge that as well. And to make sure that they give you an easier start to build your own ARM templates, they created Bicep. And Bicep is a domain-specific language, which means that, and it's focused on declarative language, so to speak. What we mean with that is that you do not have to code creating all the actions that the Azure Resource Manager needs to do. You just have to declare all the resources that you want to be created. So I only have to say, create a host pool, for instance, if we're talking about Azure Virtual Desktop for me, and specify some of the parameters or some of the properties of that host pool, just to give you an idea. So if we're focusing into or diving into Bicep and where does it stand within the whole Azure Resource Manager architecture, you'll notice that Bicep is meant to create your ARM template. So it's not meant to replace the ARM template methodology or the way to automate resource deployment within Azure. It's just an easier way to create those ARM templates that will still be the main communication for the Azure Resource Manager. And as I said in the beginning, it's, at least to me, it's very intuitive, which makes it easier to read the Bicep files, but also to create your own Bicep files. We have this cool terminology called transpiling, which basically means that we tell the Bicep engine to transpile the Bicep code into an ARM template, so we can use that ARM template for our automated deployments. Another cool thing is that it's very modular. So it allows you to focus on different components or different features or different Azure services, and to trim it down and reuse those Bicep code that you are creating over and over in different projects. So you can use actual modules. And the last very fun thing that we want to make sure that you understand is that it's open source. It has a very active GitHub repository where the engineers are actively checking any suggestions that you have. So feel free to check it out. aka.ms/bicep is the quick URL to go to. And I guess that's enough talk. As you can tell, I'm excited to do some demos myself. So, so let's just focus on getting started. So you should all see Visual Studio Code right now. So one of the things that you need to know is that Bicep is an executable on its own. So you can easily download it, install it, and make sure that you have a path reference in your environment variable path setting. So the operating system knows instantly where the executable is located and can use it. Another cool thing that we wanted to show you, even though it's optional, is the extensions that you can install within VS Code. Because there's a specific Bicep extension that will give you so much ease of creation of your for your Bicep files, that we definitely wanted to make sure that you were aware of that. So as you can tell, I've already installed the extension, and this is me getting started with my first Hello World Bicep file. By now, I hope you already have some experience in Azure and you realize that everything in Azure is focused on resources. So the same with an ARM template. If I want to get started and create some resources in Azure with an ARM template, I need to specify the resources that I want to use. So same with Bicep, you just did I make a typo? No, not yet. You just create a resource. In my case, let's start with Azure Virtual Desktop host pools, because that's where I feel very comfortable, because I know what settings and properties I can configure from the portal, but also the CLI. So I start with resource and then I give it a name. That's just a reference name. It's not the name that the resource will get within Azure, but I'll show you in just a second. And then I need to specify what type of resource I want to create as Microsoft understands it. And I also need to specify a version. And what you can see with the Bicep extension in VS Code is that it is already filling out or pre-filling auto. I was going to say using IntelliSense. It's a lot of terminology and I sometimes get lost as well. So using IntelliSense to understand what I want to do. So it's helping me to already start creating my first resources. And the other cool thing is that there's a lot of, like I said, IntelliSense within VS Code now. So I can even what they call use scaffolding, which means that it already fills out some or makes suggestions of all the information that I want to declare. So in this case, I can simply select required properties, and this will ensure that I have the minimum configuration for my host pool in my ARM template. So these are all the properties that are required to successfully create a resource in Azure. So I need to specify a name. Let's just call it Bicep Demo Host Pool. I need to specify a host pool type. And to be honest, I'm not sure which host pool types are available. And the cool new short is it Windows key combination is Control Space, and that will be your friend, especially if you want to use all this IntelliSense and scaffolding and all other coolness within VS Code. So if I'm pressing Control Alt, it will Control Space, sorry, it will now specify all the values that are valid for a host pool type. So in my case, I'm just going to go with a pool type, going to do the same trick with load balancing type. I see that it has breadth first and depth first. We'll not dive into that and each feature specifically because I just want to quickly go through it. But these are just the settings that are required for a minimum set of creating a host pool resource within Azure. So that is pretty cool. already. At least that's what I think. So let me quickly save this. And as we said, there is an option to do a transpiling of the Bicep code into an ARM template. So if I simply type in Bicep, which is the executable that I downloaded and installed, select build and specify the Bicep file, it will now generate a hello world JSON file, which is my ARM template. Let me just quickly see if I can do this. And what you see is that this actually transpiled my simple resource back into an ARM template JSON formatted resource, same host pool within the JSON file. So this is an ARM template that I can directly use to deploy this host pool resource within Azure. So I hope this already gives you an idea of how quickly you can create or get started with resource automation or infrastructure as code within Azure. I'm just quickly gonna make sure that I have my my notes with me, because there's so many cool features. I want to make sure that I address most of them. For those of you who've already worked with ARM templates, you'll know that it's not just about resources. There's also a section for parameters. So what I can do easily is create a parameter, let's call it prefix. It's already automatically asking me what type I want to specify, and I can simply specify like that. Simply specify this a default value for it as well. Another cool thing that we have within Bicep is what we call decorators, and these allow us to specify additional settings or additional, well, properties is not the right word, but basically it declares, it gives you extra information on the parameter that you are specifying. So one of the defaults that you can use is secure, to make sure that you have, for instance, secure string. Just typing and talking at the same time. And one of the other things that I wanted to address, I'll copy some code in to make it to go over the examples quicker within a second. But one of the other things that you'll notice is that I have all these weird curly things underneath my typed parameters, for instance. And what it does is basically there's a built-in linter function to make sure that you have the correct syntax, or that you are not risking building unusable ARM templates. Took me a while to get there. So for instance, this one basically notifies me that it's very cool that I created a parameter, but it's not being used within my resources. So maybe I should fix that by making sure that I use that prefix. For instance, it will make it easier for me to address those parameters within my resources. And that will allow me, as we're accustomed with ARM templates, to reuse a default template or a standard template that I created with different input parameters, making it easier to build reusable templates. So now at least that warning is fixed. So with password, there's still the warning that it's not used, but there's also another warning with my default value. So it even understands that sometimes it's not very smart, especially if you're declaring this as a secure string, to have your default value in clear text within your template. Of course, for demo purposes, this is not too much of a hassle, but at least these are warnings that the system automatically makes you aware of. So if I once again build this template, you'll notice not only that the linter functionality is within the file, but it's also giving that same warnings when it's transpiling to make sure that you are aware that your ARM template is having some syntax risks or challenges. And one of the things that I wanted to show you is that we have an option which is called the bicep config.json file to configure what we want the linter functionality to do. In this case, what you can see is we have a preset of rules declared within this file that basically says that a secure parameter default value needs to have a warning generated. If I'm using or if I'm declaring parameters that are not used, I also need to generate a warning. So if I now change these two values from warning to off and make sure that the warning is not generated anymore, and I once again run that build, then what you see is that those warnings are not created anymore. So even though they are still in the linter active right now in the code that I'm typing, it's not using that or showing those warnings again when transpiling. And this is the part where I'm quickly gonna copy over some code just to speed up the process just a little bit for the demo. So one of the other things, as I said, with the decorators is we can also use allowed to make sure that we have that allowed parameter values specified, in this case for a host pool type. And what I did is I already referenced those parameters. So what you saw within the string, I used the $sign and the curly brackets to call the variable or the parameter prefix in this case. But if I'm not specifying it within a string, I can simply just type the parameter name, and then it is used and referenced and understood within the Bicep code. And if you move over it, it will even tell you, in this case with the allowed, for instance, which values are specified for that parameter. So that will definitely help you quickly creating some Bicep code. Another cool thing is that in addition in ARM templates, in addition to parameters, you have variables. Those can also be declared in your Bicep files if you want to use specific values within your template and not have them specified as input for your deployments. And then there's one last thing that I wanted to show, which is a cool thing that I think we also need to thank Freek for, because he contributed to it as well, is that the Bicep language extension also supports usage of snippets. I just have to type res minus or dash instead of resource, and then I get already a cool list of all the different resources, snippets that are available. So for instance, if I want to create an application group, I can simply select that application group and even tap through the different settings. So that makes it very easy to quickly build your templates with code that you know is already validated. And this already gives you basically the minimum valuable set. And once again, one of the other things, and I love how this snippet also has the reference of making sure that I get the resource ID for the host pool ARM path, which basically is the host pool ID. The other cool thing about Bicep is that I can simply reference my resource by name and then use the properties of it. So I could also replace this piece of code simply by referencing hp.id. And And that already makes sure that Bicep understands that the application group needs to have the host pool already pre-created. So it has a dependency on the host pool settings. So that's basically the most parts that I wanted to make sure that I addressed. One last one before I hand it over to more cool demos from Freek, because he will show you much more advanced coolness. ARM templates also allow us to generate output to make sure that we understand what is generated. So in this case, I can simply specify the output that I want my ARM template to show as well by just stating the name, a name, the type, and then say I want the host pool name to be shown as the output of the ARM template. So quickly, just to show you that it is generating now a valid Bicep JSON file. As you can see, that's the wrong file. Hang on. So what you can see is that those parameters are also created in the ARM template, password with the type secure string, specified by the decorator, the allowed values with the allowed decorator, and all the different resources and references to it, which I find a bit harder to read than the more intuitive Bicep code.
That's an understatement.
Yes. And I'm not even going to address the changes or the extra lines of code that is required within JSON. But this is just basically, and I hope I'm not overwhelming you by speeding through the demo, but we wanted to make sure that you understood the basics before I hand it over to Freek and let him show you all the cool other things that you can do, like the modules and the other advanced topics, to make sure that you can build a great set of templates in Bicep for your Azure deployments. So you can take it away, Freek.
Yes, let me go ahead and share my screen. So as you just showed us some great ways of a lot of examples of how the VS Code extension really helps you in the authoring and the debugging and the writing and the reading of these templates. And we think that's definitely an important part of the success of any programming language, whether it's imperative or declarative like Bicep. Having these IntelliSense and VS Code extensions is really, really helpful. So we can really encourage you to install it and have that full authoring experience of Bicep. So I want to address a couple of things about the Bicep syntax some more. And for that, I have an example here, which is a virtual machine. So Esther showed you a couple of examples where a single resource was being created, and she already showed you the addition of having multiple resources and how those depend on each other. I quickly want to also dive into where that is coming from and how that is being handled by the transpiler. So again, we have a Bicep file here, nothing more fancy than Esther already showed you, with a couple of parameters, a secure parameter, and a couple of default values. But I want to focus on having multiple resources be deployed as part of a single deployment. So I have a resource here, a virtual network. I have another resource here, which is a network adapter, and I have a virtual machine. So I could go ahead and transpile this into a JSON file to see sort of see the JSON equivalent of that. So I could do that same Bicep build command that Esther showed. But we also have a new feature as part of the VS Code extension, which is actually right-click build. So I could go ahead and right-click the Bicep file here, simply say build, and have that transpile process be done for us with a right-click as well. So that results, like Esther also showed you in the JSON equivalent. Let's take a look at how the Bicep CLI handles those dependencies. So this is my JSON equivalent of the creation of these three objects. And scrolling down to the creation of the network interface, you can see that we have the type definition here, API version, naming, and a couple of properties. And I have a depends on section here. So this is essentially us telling the ARM engine before you create that network interface, make sure that also that VNet exists. Otherwise, we cannot create it, right? So this is an explicit depends on. So taking a look at the virtual machine creation in Bicep, or the network adapter creation in Bicep, there is no depends on section defined here. So how did it end up in there? It is because we are referencing those previously declared objects that Esther also mentioned. So these blue ones, these are symbolic names. So this VNet actually points to the resource we declared before, the virtual network, and we're grabbing the ID from that VNet, in this case, to make up the ID of the subnet. So because we do that, the Bicep CLI knows that the VNIC depends on the VNet, and during the transpilation process, it automatically adds on this depends on section for us without having to worry about it. It is being added to our JSON code. So this is, of course, a simple example with just one depends on line, but you can have 5, 6, 10, maybe 10 different depends on depending on how complex your deployment is. So this is really helpful in making sure that these depends on sections are always up to date and contain the information that's needed to process multiple resource creations during a single deployment. So it will definitely be a lifesaver when you have where you're struggling with depends on sections in JSON. So that's the creation of multiple resources. I want to show you another example where we dive into what Esther also mentioned, the reusability of Bicep templates and how to use modules for that. So I have another example. I have more examples in this repository, but let's focus on the one that actually shows the modules. So I have example number 9 here, and it's called actually main.bicep. And the reason for that is this is the main file which consumes multiple other Bicep files, as we'll see, as part of the modularity approach. So a couple of things I want to show you. The first thing we do is we actually change the target scope of this deployment. So if you are familiar with ARM templates and ARM deployments, you probably know that the default target scope is always a resource group. So you are creating multiple resources inside a resource group. But there are many cases where you are deploying resources into multiple resource groups, or you maybe into multiple subscriptions. So you have the option to change the target scope from anything from a management group, a resource group, a subscription, or a tenant. And to make sure that we can deploy towards multiple groups, we change it into a subscription target scope. And next, I want to show you that sometimes you might want to deploy resources conditionally. So based on whether or not a certain condition is true or false. So in order to do that, we have the if statement, the if keyword here as well. So in this case, I have the declaration of a resource group creation. So we are essentially creating a resource group, a resource in Azure, but we are only creating it when this condition is met. So if deploy resource group is true, which is actually a parameter Boolean that we collect as part of this template, only then this resource group will be created. So this is the declarative way of creating resources conditionally, which can be very helpful if you have larger deployments. Another thing before we dive into the modules is we have a couple of parameters here. So some of them have the common variables like strings and integers and booleans, but we also have an array here of 2 different types of Azure Virtual Desktop backplane components, one for full desktop and one for remote apps. So we'll use these to also create multiple instances of the resources using a module and also leveraging what's called loops. So before we dive into the loops, first let's take a look at a more simple module declaration. So in this case, we're using the keyword module instead of resource. We again have that same symbolic name, and we're pointing to a Bicep file containing the resource declarations of, in this case, a virtual network. So we have just extracted the declarations of that VNet, put them into a separate file, and reuse that inside our main file. We then set a scope. So again, we're using that RG, which is a symbolic name pointing to the resource group we just created, which means that all of the resources that are declared in this file will be deployed to this scope, meaning inside this resource group. We give it a name and we pass it a couple of parameters. So this is us passing parameters that we collected inside the main file towards the module file so that the module file can use those in order to process the resources that it contains. So let's take a look at that 9 VNet module file. And it actually just looks like any other Bicep file. It has parameters, variables, and resources, and could also have outputs. The reason is that it looks exactly the same is that this is just any other Bicep file. So any Bicep file can also be a module file. There's nothing you have to do to make it a module. So I could actually go ahead and actually transpile this, build this into a JSON file and feed that separately to the ARM engine. But instead of doing that, I'm leveraging this as a module inside, like we said, the main file. And that's that piece of code that well, points to that 9 module file. The example I wanted to dive into more is also using that for loops approach. So sometimes you might want to create multiple instances of the same resource, multiple VMs or multiple Azure Virtual Desktop environments in this case. So we are combining the module approach with also, in this case, a for loop. So in this case, we are using that another module file which contains the resource declaration of my Azure Virtual Desktop environment. And we're telling the ARM engine not to deploy this once, but deploy it for each AVD backplane inside the array AVD backplanes. So scrolling up to that array we had before, those are these 2 declarations, right? So we're creating 2 Azure Virtual Desktop backplanes, one for desktop and one for remote app, just with one single declaration inside this module. So again, we're using that same scope and passing it a couple of parameters, also, of course, coming from that AVD backplane array. So that's using the first way of using for loop is looping through a set of objects inside an array. There's another one I want to show you, and that's actually inside one of the other modules, which is the VM module, where we're not using that for loop approach, using that array, but instead looping through a set of numbers, in this case, with an I in one range. So we have the same resource declaration here for the virtual network, again, with the type and with the API version. In this case, we say for I in range 1, 2 number of VMs, and number of VMs, again, is a parameter we're collecting as part of this module, which, by the way, has a default number of 5. Deploy this resource. So it will be deployed 5 times instead of 1. It will loop through this, this indexer here. So this indexer also becomes available throughout the declaration of this resource. We can also use it to concatenate and create a unique name, for in this case, the virtual network as well. So we are concatenating using this syntax here, the default VNet prefix, for example, could be VNet. And then the first NIC will become a VNet -1, -2, -3, -4, etc.
Yeah, so this ensures that even though we're looping and we're creating multiple instances, that each VNet instance has a unique name.
Yep, exactly. Yep. And that allows us to create resources multiple times only by declaring them once, which is obviously not unique to Bicep. ARM template can do it as well. But this is, I think, a much more easy to read and to understand syntax compared to the JSON language.
Yeah, I'm not going to argue with that one.
Oh, good. And then similarly for the virtual machine, we're also doing the same thing. So we're also creating 5 virtual machines. We're concatenating the name to make sure that we have unique names for that virtual machine as well as we loop through the resource declaration.
So, and I do notice you are now explicitly using the depends on feature within this module. Does that have a specific reason, or is that just to make sure that it is linked to the correct VNet?
Yeah, it's good that you actually point that out, because as you can see, we are pointing to the VNet ID in this resource here. So it might imply that we're also creating that VNet as part of this, but we're not, because that VNet is created inside another module. And that is where we leverage the existing keyword. So it seems we are creating a new resource here for the VNet, but instead of creating the resource here, we're telling the ARM engine that we want to point to an existing object, which is created outside of our Bicep file, in this case, in another Bicep file, but it could already be created by someone else or created by another deployment or another administrator somehow. So this allows us to still point to that existing resource and have that available there. This is just to show you that you can also do explicit depends on. So although I'm still using that ID of that VNet, which should make sure that an implicit depends on is being added, to answer the question, can you still do this explicitly? Yes, you can, using these depends on sections. But like you said, that's a good bridge to the next topic I wanted to cover, the existing keyword, which is super powerful because it allows you to get properties of objects that are already there, but not declared inside your Bicep file. So we are starting to build up more modules and more files and more resources along the way. And sometimes you might want to get a visualization of what it actually looks like, what you are deploying. Luckily, we can. So we have the option to do a visualization of our main file here. So either go to the upper right to open the visualizer side by side, or right-click the Bicep file and say Open Visualizer. So let's do the latter for now. And as you can see, it automatically generated a graphical interpretation of the main Bicep file. So without having to do anything with Visio or anything else, it just auto-created for us based on what we declared inside the Bicep file. Also note that recently they also start to add icons for each of these objects as well. They have a couple of more to go, but obviously that makes it much more easy to read and digest as well. And it differences between resources and modules as well. So these folder icons here are the modules, and inside those modules I have the resource declarations. And this is also interactive, so I could just go and move this around to make sure that it meets my needs in terms of the design that I want it to be, and have this maybe as the documentation of my Bicep file. Another great thing that it's also interactive and auto-updating. So if I were to open this Bicep file and have the visualization side by side, and for example, I would start to add a new resource inside this main file. So let's just copy this resource group declaration, give it a unique name real quick. And what you'll see on the right-hand side is that a new resource group already appears and is already there. So as we are authoring this Bicep file, along the way, we get the visual representation of what it looks like inside this visualizer, which is pretty cool, I think. And also, if you are accidentally making errors. So, for example, let's introduce an error in the AVD module. Let's make a typo inside the resource declaration. It auto-updates. It shows you that there is an error and that the rendering graph may not be accurate, but more importantly, it also points out the module and the resource group that depend on that error. So I can instantly dive in and fix the error by, of course, removing the typo here, and then the visualization is good again. So really powerful asset, I think, in the overall authoring experience as part of the VS Code extension.
I do have one quick question in the chat, Freek, in regards to the existing declaration within the module.
Mm-hmm.
So you used existing to reference an existing resource within Azure. And the question is, how will Bicep fetch the resource ID if that VNet lives, for instance, in another resource group? So I was not 100% sure, but I think because you already use target scope to declare the scope to be subscription wide, that it can look into different resource groups to make sure that it retrieves the correct ID.
Yeah, exactly. And you can still do that explicitly as well. If you know the exact location, you can also use that same the same approach to get that resource from another subscription or another resource group explicitly. But it's due to the scope. Yep, you're right.
Okay, perfect.
Okay. So that's the visualization that I wanted to show you. And of course, you might have already invested into JSON templates. You might already have a whole repository of JSON templates that you created before or downloaded from GitHub or anything from the Azure portal as well. Is there a way to retranspile or decompile those back to the Bicep language? That is always the question, and the answer is yes. So let me show you how that works. So I have a example here, number 7. I don't actually. Where's my JSON file? Wow, I must have accidentally deleted that. That was interesting. Okay. Well, anyway, the command to do that is bicep decompile. Do I have another one here? I do. 9 old school template.json. So what this command does, it might not work because I didn't test this real properly, is transpile this JSON file back to a Bicep file. So this is really helpful if you are coming from an ARM background, if you have invested a lot in ARM templates, if you want to reuse those technologies, you can decompile them. Do note that decompiling is at best ever process. So although it results into a valid Bicep file you can deploy into the Azure portal, make sure that investigate what has been created, because sometimes Bicep has a couple of things that ARM templates do not. For example, the symbolic names that will be generated. You might want to address those and take a look at if they are created accurately. But this is really a helpful tool, again, inside your range of tools as part of the CLI extension to help you transition from JSON templates to Bicep. The other great thing, besides the fact that you can do that decompile, is also actually using those templates as part of a module approach. So let's say, and I think that is where that example was coming from. Let me just remove that Bicep file. So I have a JSON file here, an ARM template. Let's say I want to use that, not transpile it, not decompile it back to Bicep, but instead use it as a module. I could create a new module. Let's just call it demo for now. And I could point to that existing JSON file instead of the existing Bicep file. And as Esther also showed you, actually also have the scaffolding available. So we are scaffolding the required properties of this JSON file while consuming it as a module. So I could do the scoping, which is the resource group, enter in the couple of names and a very secure password here. But just to show you that you can leverage these JSON files as a module inside the Bicep code, which is really helpful if you are transitioning from JSON towards Bicep. So that's using ARM modules ARM templates as modules. So before I hand it over back to Esther again, one thing I want to show you is bringing it all together. So left-hand side, I have an example number 6, which is a main.bicep file, again, with all of the things we just covered. So the target scopes, the modules, the secure parameters, the for loops, etc. So in this case, what it actually has is a single main file, which is a little bit bigger, about 300 plus lines. But it actually leverages all of the Bicep modules you'll see here on the left-hand side. So I have separate models for my Azure Virtual Desktop backplanes, my networking, my template images, my log analytics, and so on and so forth. So this is a sort of a production usage resulting into a full Azure Virtual Desktop deployment by leveraging the modules that I have in my repository. And that's really all about reusing these modules. So I could take a subset of these modules, bring them to another subscription, create a new main file, pass a couple of parameters, and make sure all of these resources are created. So last thing I want to show you is actually transpiling that into a JSON file, just to show you what the end result looks like inside JSON. And if we open it up, we can actually see that it created a huge JSON file of over 2,000 lines of code. So imagine having to code this from scratch. You probably don't want to do this. So the reason why this file became so large is, one is, of course, the much more cleaner syntax, less syntax overhead inside the Bicep file, but also because it leverages all these modules. The transpilation process includes the declarations of all of these modules inside the main file, resulting into one single JSON file I could feed into the engine and have all these resources be created. So just to show you an example of a more production-ready example using Bicep.
Awesome.
Any questions you want to address, Esther, before we?
Yes, everyone is still very excited about the existing keyword and how to reference. So basically what I didn't fully get from the first question was, if the scope indeed is a subscription, then the VNet name, for instance, is not unique. So how are you going to make sure that it does pick the right VNet in the right resource group? So can you show, the question basically is if you can show within one of the Bicep files how you are making sure that it's picking the right VNet.
Yes, not right away, but maybe I can prepare that while you are covering the rest of the day.
Nice. Yeah, sure, no problem. Then I'm just quickly going to share my screen again and explain why I'm giving Freek just a little bit time to prepare that correctly. Because we wanted to make sure with this session we did not only share the fun of creating your Bicep files, but we also wanted to make sure that you understand how in your infrastructure as code you can actually use those Bicep files directly. So basically what we're going to do is we're going to put Bicep into GitHub Actions and show you how you can use them. So right now, there is still a tiny footnote, well, a couple, a limitation to using Bicep files. So the limitation currently is that you cannot reference via URLs or UNC paths, basically your Bicep files. You need to use local Bicep files. So this, if we're talking about GitHub Actions, basically means that you need to make sure that you check out your repository files containing the Bicep files to your agent, and then make sure that you use those Bicep files. Because the other cool news is that with Azure CLI 2.20 or PowerShell 5.6 and up, you can directly use the Bicep file as your template instead of having to transpile the Bicep file to an ARM template and then use that ARM template. So the CLI and PowerShell AZ module now fully support using the Bicep file as your template input. And the other cool part with when using the Azure CLI is that the Azure CLI is also capable of installing Bicep, the executable, if it's not already on the agent. With PowerShell, unfortunately, you have to make sure that the executable is already installed on your agent. But the good news is if you're using the Windows hosted or the Azure hosted agents, and in this case, I just double checked the Windows latest agent configuration. What you'll notice is that Bicep is already pre-installed on that hosted agent, including the CLI, Azure CLI, and the PowerShell tools. So this makes sure that your agent is fully capable to instantly use those Bicep files. If you're using the Azure CLI, or the PowerShell AZ module for the new AZ deployment commandlets. Focusing back on my GitHub action example, the same goes for Azure DevOps pipelines, because they are both using the same base image for their hosted agents. But if we're looking at Bicep in combination with GitHub Action, so as I mentioned before, I had to use an extra action to prepare my agent to use Bicep. Now I can just skip that action and immediately deploy my ARM resources with Bicep, and in my case, the Azure PowerShell module. So just diving into a quick example. One of the things that you might have noticed with all the transpiling that we've been showing is that we did not focus on a parameter file. And that's simply because Bicep will generate the ARM template, the JSON format, but it will not help you in generating or transpiling a parameter file that is normally used in combination with your ARM template. For me, the easy way out is to use what they call a template parameter object, because that's another parameter for my new AZ, in this case, resource group deployment, because I scoped it to just one resource group. But that allows me to specify all the input parameters for my ARM template or my Bicep template, and then automatically deploy it with those generated preset parameters. You can also use a default JSON ARM template parameter file in case you still feel comfortable using that. But for me, this makes it more flexible, especially using PowerShell scripts to dynamically make sure that I have the right parameters. So, and as I specified, you can now use that local Bicep file as your template file, and then just use the new AZ resource group deployment commandlet to actually run it. And then what you'll notice is, in my case, in the example, and I'm just going to skip over the video because I do notice that we are running short on time. But what you'll notice is that it does reference that local repository checked out Bicep file, uses that with my new AZ resource group deployment commandlet, and then generates, in my case, a host pool, application group, and a workspace based on that JSON file. So as you can see, it now states provisioning state is succeeded. And I have the resources actually in Azure. And as I said, you have to take my word on it, because I'm just going to skip over the video just to make sure that we have enough time to also show you how fast basically all the improvements and feature additions to Bicep is going. So as you can see in August last year, 2000, that's even, yes, that is last year. I'm getting the dates mixed up. We started with version 0.1. And currently we are already with version 0.4. And don't get confused by the fact that it's still V0, because it is fully usable in production environments with all the added features, as you can see, especially focusing on loops, for instance, and the conditionals to use it in production. Yes, I think it is definitely production ready, because I'm having a lot of fun with it. And so far, I haven't managed to break any of my ARM template coding or deployments in Azure yet. So that's a pretty awesome accomplishment, because I had to use my Freek speed dial button a lot before when I was using ARM templates. And unfortunately, it wasn't always DNS that we could blame. So it was also some typos and other dependencies, so to speak. What we're really looking forward to is the 0.5 version, which is coming in September 2001, which is basically just a couple of days away. So as you can see, that also will increase the linter functionality that is very helpful. So that means that we're going to add more, or they're going to add more rules to that linter configuration file, giving us even more feedback and preventing even more syntax errors within our code. And then, of course, we are definitely looking forward to the version 1.0. That will be released end of year, as is the prognosis right now. But judging on the speed of improvements that the engineers are adding to Bicep. I'm still very hopeful that it might just not be a Christmas present, but maybe even Thanksgiving or hopefully earlier. Before I'm gonna see if Freek has a cool answer for our audience question of the day. Just one quick call to actions. Just to make sure. So as we mentioned at the beginning, aka.ms/bicep is your go-to URL for all the coolness on Bicep. So it directly links you to the GitHub repository that not just has the executable installation instructions, but it also has all the references to the Learn module, to all the documentation reference guides that are out there. And it also allows you to become an active contributor to the Bicep project. For instance, contributing through adding more snippets or snippet examples like Freek did. Or writing a whole book about it. But definitely what I noticed is even with the simple feedback that a function is not working as you expected it, it's not as intuitive as you wanted it to be, they are monitoring all the pull requests, all the other feature requests very actively, and I just love the interaction. So definitely check it out, and if there's anything that you can give back to the engineers, feel free to do so, because they would love to hear from you. Again, we switch screens again, Freek, or did I not give you enough time?
You didn't give me enough time, but that's okay. I did find the example of pointing to an existing resource group outside of the subscription. Also make sure to add that in the chat window. But I will take up on the challenge to find the answer and post it in the chat later today.
Okay, perfect.
So not right now, unfortunately, but we'll get there. No problem. So yeah, with that, we'd like to thank you to the organizers for having us. First of all, it was great, and hopefully everyone enjoyed the content, the demos, etc. If you have additional questions like this one or other ones, feel free to reach out to either of us, Twitter, email, LinkedIn. That is all fine. And yeah, anything else you want to add, Esther?
No, I'm just happy that you gave us the opportunity to share our excitement on Bicep, and to once again have a lot of fun with all the demos. And I really appreciate the challenge that you also gave Freek, because now we have whole new ideas of enriching our demos even further. So I have full confidence that he will get back to you in a couple of hours. I'll give you some slack, Freek. It's a working day after all, so we all know how crazy those get. So once again, thank you very much for having us, and definitely feel free to reach out to both of us. We love to share our knowledge and experience.
Awesome. Thank you very much. I sure learned a lot in today's session. I have been working a lot with Terraform mostly, but I really can see the benefits of using Bicep in some scenarios. For example, the 0-day support for new resources is maybe one of the most exciting features, because Terraform has some delays on some new services. I'm not sure if Azure Virtual Desktop, for example, is supported in Terraform yet. It was at least very delayed.
It was not till I think 2 weeks ago, where Jen Shearing, and I know a colleague of her, and unfortunately I forgot her name, shared a post that now Azure Virtual Desktop is also included in the Terraform providers.
Awesome. Better late than never.
Correct.
Yeah.
Yes, and I want to emphasize on the fact that both Freek and I do not want to make this a competition on whether you should pick Bicep or Terraform.
Sure.
Just always go with the right tool for the right situation or scenario, so to speak.
Yeah, I work personally as a consultant, and I always try to use the right tool for the project. So yeah, it depends on the requirements and the situation and so on.
Yeah, we also have love for Terraform.
Yeah. All right, thank you very much, guys. I'll stop the recording now, and I'll post the recording later today.